If you want help with this worksheet, I'm glad you're listening, and you should probably open the worksheet in Notability, maybe do a split screen if that works for you. The worksheet is 9.5 practice. Is the equation balanced? The guiding question, can we get something for nothing? And the goal, I can identify if an equation is balanced by applying the law of conservation of mass. The law of conservation of mass, and I'm reading here now, is that matter or mass cannot be created or destroyed, but can only rearrange and change forms. So it's a scientific law or kind of a rule that things seem to follow in nature. In the picture below, highlight the words like this: reactants with yellow, yield with orange, and that means produce, and products in green. So I see in the words here reactants, and then yield, and then products. And then it says in the second bullet point, then highlight the reactants and the products in the formulas and pictures to match. So looking at it, the formula is the part where the big blue arrow is pointing. So this part here is one of these is a formula, I guess, is the better way to think of it. The formula for methane, the formula for oxygen. And then the whole thing is called an equation. This whole long thing is a chemical equation. So let's highlight in the equation the reactants and the products. So remember, reactants are the starting compounds that are on the left. And there's the formulas and words. And then these pictures also represent those reactants. And then they yield or produce the things that we see here on the right. And so the question here that I'm going to read now, right here, does the equation show the law of conservation of mass? Does it show that matter or mass cannot be created or destroyed, but can only rearrange? And if it does, we say that the equation is balanced. The number of atoms in the reactants and products are equal. So here's what we mean when we say they have rearranged. Here I see, and maybe I'll take this coloring off again. I see a black atom in the middle, which is the carbon, and I see four, it's kind of hard to see all four, but four white hydrogens around it. So this is our CH4. And then I see two red connected, that's two oxygens that are connected. And I see that I have two of those molecules. So each one is an O2, and there are two O2s. So I see that up here. And now those atoms have just rearranged, and now they're just bonded in a new way. Here's my carbon again, and here's my four red oxygens again, and my four white hydrogens, but they're all bonded in a new way. So eventually we want to be able to just look at formulas to see that relationship and see that they are the same number of atoms on both sides. So in this practice, we will count atoms to decide if an equation is balanced. Here are the steps. Step 1, we're going to underline each element and count how many elements are shown and write it below the line. Then step 2, we're going to compare each element from the reactant to product to see if they are the same. And then step 3, circle if it's balanced or not balanced. All right, so back to step 1. Let's do this with this graham cracker and s'more equation. If you watched the video, then you know this is trying to show making a s'more by using a chemical equation. So I see GC for graham cracker, and I'm going to underline and count. There's only one there. M, underline and count. There's only one. CP for chocolate pieces, underline and count. This time I see 3. And then I have the arrow, yields, and here on this side, underline GC, I have 2 here. M, I have 1, and CP, I have 3. So I have counted all the atoms. Step 2, compare each element from reactant to product to see if they are the same. So I'm going to start back at the GC side, and I see 1 GC, and now I'm jumping over to find GC over here, and I see 2 GC. So that is not the same. Let me highlight in the yield sign again. Remember, we're comparing from one side of the arrow to the other. 1 GC cannot become 2 GC like magic. And so this equation is not balanced. Let's try it with the next one, which has real atoms or real formulas. First step, underline each element and count how many atoms are shown and write it below the line. So H2, I see 2 H's. This is capital Cl for chlorine, and there's 2 of those. And then over here I see H and the chlorine bonded. So I'm going to underline them both separately. So I'm going to write kind of small here. But remember, the coefficient multiplies. So 2 times no subscript for H means there's 2H. And 2 times no subscript for Cl means 2Cl. Now, step 2. Compare each element from reactant to product to see if they are the same. So here's where I'm going to jump across. I'm just going to draw so you can see what I'm looking at. On this side, there's 2 H's, and when I go across to the other side of the arrow, there are 2 H's here. It's a little bit different arrangement, but there are 2 H's. The Cl's on this side, there's 2 Cl's, and over here there are also 2 Cl's. So that's the same. That means both elements are balanced from one side of the arrow to the other. So that one, yes, is balanced. That's how you do this worksheet. Do your best.